Hello, this is Mrs. Lewis. Today we're going to look a little bit more deeply into the physics of work. When we talk about work, there are two important things to consider. The force, which we know is a push or a pull, and the displacement, which is how far an object moves. The force must cause the displacement. That's the key to understanding whether work is done. If we exert a force and it doesn't cause a displacement, there is no work done. Let's look at some examples. For instance, as you're sitting and watching this video, you're not moving anything. There is no displacement, so therefore there is no work. You must have a force and you must have a displacement. The force must cause the displacement. Suppose you were standing waiting for a bus and you are holding your heavy briefcase off the ground. You would exert a force to hold that briefcase, but there is no displacement, therefore there is no work. Supposing you took your dog for a walk and it was a stubborn dog. He wouldn't move. You pulled and pulled, but there was no movement. Without any movement, there is no work. This is a little more difficult to understand. Suppose you were moving with a constant velocity. You know that if we move with a constant velocity, there is no force pushing us. And supposing you were holding this briefcase, well, you would be exerting a force to hold the briefcase. You would be exerting a force opposing the force of gravity, but that would not be in the direction that you were moving, so therefore there would be no work. When we calculate work, we consider the force and the distance. So in a very simple example, here's someone who is moving a box, and he's exerting a 40 Newton force on the box, and the box is going to move 5 meters. So therefore, exerting the 40 Newton force, and over the 5 meters, it's in the direction of the displacement, so therefore there are 40 joules of work done. It's a little more complicated than this because we must consider the direction when we calculate work. So the more proper formula is force times displacement times the cosine of theta. And theta is the angle between the force and the displacement. We use the cosine of theta to help us figure out what part of the force is in the direction of the displacement. For example, if we were lifting a book, then the angle between the force, which is up, and the displacement, which is up, is 0. The cosine of 0 is 1. Suppose we were applying a 5 Newton force and we lifted our book 1 meter. Then, using the more proper formula, we would say work equals 5 newtons of force over 1 meter of distance times the cosine of theta, which is 0 degrees, and the cosine of 0 is 1, so therefore, in this case, we did 5 joules of work. Let's look at this example. This time, the girl is pulling on the suitcase, but she's pulling it at an angle, okay? So she's pulling with a 45 newtons of force, and the angle between the force, which is pulled up at this angle, and the horizontal movement is 50 degrees. When she does this, the suitcase moves 75 meters. So, using our formula, we would say work equals 45 newtons of force over 75 meters of displacement, and to get the direction, we take the cosine of 50. When we multiply this out, we get that the work was 2,170 joules. Work can be both positive and negative. If the force works to move the object forward, it's positive. Here we have a force pushing on this object, and the displacement is moving it forward, so the work is positive. However, if the force opposes the movement, so here the object is moving this way, but there's a force pulling it backwards, then the work done by this force is negative. For instance, if we had this little wind-up car, we wound it up and it was accelerating forward, causing it to have a forward displacement, but we had a string on the other side and we were pulling on the string. Then we were pulling with a force in the opposite direction to the displacement, and therefore the work done by this force would be negative. Let's look at some other examples. Suppose we had two forces working on this object number 1. One force of 10 newtons is pushing this object forward. Another force of 6 newtons is pulling the object backwards. The object will end up, if we add up these forces, the object will end up moving to the right. So therefore, the blue force here is positive. It's in the same direction as the movement. The red force is negative. It's in the opposite direction as the movement or the displacement. In this case, we have two forces, two blue forces, and they are pulling on the object in this direction. They're both pulling in the same direction. The object is going to move to the right, so therefore, both of these forces do positive work on the object. Let's look at this case. Here we have object number 3. We have two forces, a 2 Newton force and a 3 Newton force, pulling this object to the right, and we have a 5 Newton force pulling this object to the left. Well, these forces are balanced. There's not going to be any movement, no displacement. Without displacement, there's going to be no work. One last thing to consider is if the force is perpendicular to the direction of movement, then the angle between the force and the displacement, this angle here, is 90 degrees. The cosine of 90 is 0. So if we multiply this side of the equation by 0, there's going to be no work done. So if you are carrying your book with your hand over your head and you're moving at a constant velocity across the room, the force you are applying is perpendicular to the displacement, so the cosine of 90 is 0. No work is done. We'll be working with some problems on work in class today. Good luck.